Hey, we're talking about finding average rate of change, and our function is defined here as h of x is equal to x cubed plus e to the 2x, and we're on the interval between 0 and 1. And this is what we're going to be using to find the average rate of change. So we take 1, this is our f of b, and our b happens to be 1. So h of 1 minus h of 0 over 1 minus 0. So we plug 1 into our function, minus, and plug 0 into our function, and this should be 1 minus 0 here. Okay, well it is now. And then we just do the arithmetic and we end up getting e squared. And I'm just going to approximate that to decimal places, no big reason why, just so you get an idea of where e to the squared is at on the real number line. But approximately 7.39. Now here was our original function. Now this is the average rate of change. Let's go ahead and find the instantaneous rate of change at both of our endpoints 0 and 1. So here is our function h of x, and we want to take the derivative of this because the derivative is going to give us the instantaneous rate of change at both of our endpoints. So the derivative of x cubed is 3x squared, and the derivative of e to the 2x is 2e to the 2x. Remember, you take the derivative of the exponent, bring it out front, and then just rewrite the whole thing. Now we plug 0 in, and we end up with 2. We plug 1 in to our derivative, and we end up with 8.39. Now 7.39 falls in between 2 and 8.39. That's good, because remember, this is the average. This is the instantaneous at 0 and the instantaneous at 1. Now I'm not going to have a graph for this particular problem, and really, I guess I just didn't put a graph up, but you need to just go ahead and trust the math. Sometimes it's not good to look at graphs, but I do have a graph for the next problem. Okay, so our function here is f of t is equal to t squared plus 1, and we're on the interval between 0 and 2, and the average rate is f of b minus fa over b minus a, and so forth. And I've just kind of labeled this differently, but oh well. Okay, so we do f of 2 minus f of 0 over 2 minus 0, so we plug 2 into the function, plugging 0 into the function, and we get the average rate, as you can see down here, is equal to 2. We're going to find the instantaneous rate of change, take the derivative, plug in 0, you get 0, plug in 2, and you get 4. Now, remember what the average rate of change was. The average rate is 2. And of course 2 is falling in between 0 and 4. Here's a picture here that I've got drawn out. So this is our function, t squared plus 1. This line right here is the instantaneous rate at 0. So you can see that the slope is 0. And then this line right here, you can barely see, is the instantaneous rate at 2. And we said that it was 4, so this line here has a slope of 4. And then this green line here passing through, this is the average rate. Okay, this is the average between the slope of this line and the slope of this line. This is going to be the average. And we said that that average was 2. So real quickly here, if you can imagine finding the slope at, let's say, 0, the slope at 0.5, the slope at 0.75, the slope at 1, the slope at 1.5, and you took all those slopes, you added them up, and then divided by the number of times you did that, you would get closer to this guy right here, closer to the average.